We've studied problems that involve simple interest, where there is a one-time payment of interest at the end of the investment period. Most investments involved compound interest here. Compound interest is where the interest is regularly credited to the account so that it can begin to earn interest along with the principal. Compound interest can be modeled with an exponential function. This is where we need the exponential function. So, most real-world investments involve compound interest. Compound interest can be modeled with an exponential function. Okay, let's take a look at an example here. Okay, let's say that the total amount of $10,000 was invested into an account that earned 5% annual interest compounding yearly. And this can be modeled by the equation y equals, remember, our principal times the interest. Okay, now $10,000 is the principal, the initial principal, the initial amount of money that you've invested into this account. Our interest, it says, according to the problem here, it says it's earning 5% annual interest. Okay, this annual interest is 5%. So you're going to add that to 100%. And this 1.05 represents 105%. Okay, so this 105% is what's going to give us the amount of interest. But you have to also calculate it raised to the n number of years. Okay, that's the exponential part. And so this is our formula. Okay, the principal, the rate, and then the time is the exponential form. Okay, 1 year, let's say we have this in 1 year, okay, so n equals 1. And so we're going to plug these all into our formula here. $10,000 times 1.05% at 1 year. So that means in 1 year, you're going to earn $500 interest on $10,000 of an investment. You add that, by the end of the year, you're going to have a total of $10,500. Pretty good investment, isn't that? I would say so. We're earning $500 at the end of the year. Okay, now in 2 years' time, that means n is 2. Okay, so we plug in our formula 2 for n, and that's going to give me $11,025 at the end of 2 years. That is really good. So if you keep your money in the bank, this is good incentive for us to save our money. 50 years, if we do this for 50 years, n is 50, so you plug in 1.05 raised to the 50th power. Okay, of course you're going to be able to use the calculator for this. Okay, this approximately gives us $114,000 of $114,674,000. So let's say that once you get into college, you invest $10,000, or your first year, let's say, okay, first year of working, you earn lots of money and you save up your $10,000 in a savings account or an investment that earns 5%. By the time you are ready to retire, you will have $114,674 in your bank account, in your investment account. And that is very important, actually, for you to see and to realize, because when we're young and we save our money, we work on saving our money, then, in 50 years when you're old and you might need this for medical expenses or to help with a house or other expenses, emergency fund, that is very important to realize, okay? Now, that means you get $104,674 just in interest over 50 years, just by leaving $10,000 in the bank for 50 years. Okay. Now, hopefully that will be some good tools for you to take a look at some of these problems here. And there is your homework assignment. Okay, and hopefully these will help you to see and understand a little bit more these exponential problems and helping us with real life situations here.